Welcome to this session of the 5th International Symposium on Multidisciplinary Studies and Innovative Technologies. My name is Emir Köksal. I'm a professor doctor in the Department of Mathematics of 19 Mayıs University. The name of the first speaker of this session is Ayşe Nihan Basmacı. The title of her talk is Frequency Analysis of Electromagnetic Waves in Tripartite Photonic Crystal with Adjustable Part Lengths. Duration of each presentation is 10 minutes.
Can you hear me?
Sure.
Yes. I am Ayşe Nihan Basmacı from Tekirdağ Namık Kemal University, and we will talk about the propagation of electromagnetic waves frequency analysis in tripartite photonic crystals with adjustable part lengths. We will first take an overview of the literature, and then we will obtain electromagnetic wave propagation frequencies for 4 different photonic crystal structures whose lengths can be adjusted. And secondly, we will talk about the theoretical analysis made in this direction. And thirdly, we will discuss the results obtained as a result of the theoretical analysis mentioned in the second step. And lastly, we will end the presentation by mentioning the difference of the most recent studies. From most recent study that I made, the difference I will talk about, the novelty of my study from the other studies that are presently here in the literature. Yes. Let's start with the literature studies that are made upon the photonic crystals. Let's take a look the literature. And in the upper side, you can see a photonic crystal structure in the left upper side of the picture. I will mention about it. Here you can see a photonic crystal structure formed by holes that you can see the holes in the photonic crystal structures area, and in this photonic crystal structure an optical wave propagates through it, and this propagation occurs along the R side of the structure with an angle of 90 degrees. This structure is artificially prepared. This path is artificially prepared. What is artificially mean? It's prepared by adjusting the material properties of the photonic crystal, and so I can say it's artificially prepared. And here you can see that the electromagnetic wave propagating with an angle of 90 degrees and with a shape of R-shaped to the right side. It bends to the right side, and the electromagnetic field distributions is you can see the electromagnetic field distributions is also seen, can be also seen from the figure. And in the figure which is located below, here you can see you can also see a photonic crystal structure, and you can also see the electromagnetic waves propagating along the photonic structures. And from this figures, I can say eventually the summary. In order to obtain these bending angles in the first picture, in the relevant structure, the differentiation of material properties was used. And here, as shown in the below right figure, the same logic as mentioned for the first figure, an optical wave propagation occurs also. And in the figure 1A shows the photonic crystal structure, the layered photonic structure arrangement. With this structure arranges with two layers which are colored in red and green, and it is realized periodically. These layers put one by one, and this layers put periodically, and it is produced like this way. And when we examine figure 1B in detail, we can see the radiation, or in other words, propagation of the reflected waves. Unlike other studies, all the studies in the literature examines the propagation, the characteristics of the wave propagation, transmitted wave propagation. But unlike other studies, in this study shown in figure 1, reflected waves characteristics, in other words, backward radiation, is also examined. This is its study's novelty. And here in these figures, you can also see artificially prepared paths, like I have mentioned before. And we talked about their properties on the slide 4. And these structures these structures can be also called photonic crystal waveguides, because the electromagnetic wave can be guided. Yeah, here you can see with how we can guide it by adjusting the material properties of the photonic crystal. You can guide the electromagnetic wave propagating in these structures. Yes, here this slide. In this slide, you can see where photonic crystals are also used in, and I can reply it, they can be used in medicine too. And for instance, in this surgery, here you can see an electromagnetic wave is sent to the body, and in the probe, in the black colored probe, there is a photonic crystal structure, and with the help of this structure, electromagnetic waves, frequencies, and amplitudes can be adjusted. In the theoretical analysis section, what will we discuss? In this section, electromagnetic wave propagation will be examined in photonic crystals containing 3 parts, and we call them in this study as tripartite, and we call the photonic crystals containing 2 parts as bipartite. And in the theoretical analysis part, I will talk about the characteristics of electromagnetic waves of bipartite and tripartite photonic crystals, especially their wave propagation frequencies. I will analyze. I will mention. Sorry. Here you can see a one-dimensional photonic crystal structure. And here the material property of the structure is the same at every position along the x-axis. The material property of this structure is same at every position along the x-axis. And it's a one-dimensional photonic crystal structure basically. And in order to obtain the electromagnetic wave propagation frequencies in photonic crystals, we can use Maxwell's equations. You can see these Maxwell equations given in 1A to 1D. And from these equations, electromagnetic wave propagation frequencies, omega, will be calculated with the help of these equations. Particularly, equation 2 is obtained. Using 1C and 1D Maxwell equations. Here you can see 1C and 1D, equation 1C and 1D. Using these equations, we can obtain equation 2. And to solve equation 2, this electromagnetic wave is expressed as a sine wave. Should be expressed as a sine wave. And the wave equation, and expressing this electromagnetic wave as a sine wave, equation 3 is obtained as seen in the slide 11. Here you can see. And in figure 12, the three-partity photonic crystal structures. We can analyze the electromagnetic wave propagation frequencies in this photonic crystal structures, which has 3 parts, and we can call it, I said it before, the three-partity photonic crystal, and we will analyze its frequencies, electromagnetic wave propagation frequencies, and these three-partity photonic crystals parts can be adjusted in different lengths. You can see it, the positions of x1 and x2, and here I can say that all the material property parameters of each part of these three-partity photonic crystals are different from each other. All material properties of each parts are different from each other. It's important. And here you can see the boundary conditions. Boundary conditions clearly from this figure. You can see the boundary conditions clearly. The intermediate regions, middle regions. The boundary conditions of part 1 is equal to part 2, and boundary conditions of part 2 is equal to part 3, and part 1 and part 2, the conditions where defines the part 1 and part 2 intersects, and part 2 and part 3 intersects, is called continuity conditions. And in the left side and right side, the boundary conditions is equal to 0 because it's air there. And also I can say that these 3 parts are perfectly bonded to each other. I can say it's, I should say it because it's important. And if the wave equation is solved in line, if the wave equation is solved in line with wave equation, equation 3 is obtained by using Maxwell equations 1C and 1D. You can remember it from the previous slides. And if the wave equation is solved in line with what has been found so far, I can say, in terms of BCCs, boundary conditions, a non-trivial solution is encountered. And in order to find the exact solution, the coefficients determinant must be solved with the help of BCs, boundary conditions. After solving equation 3 with the help of boundary conditions that are found in the previous slides, therefore frequency values omega can be obtained with the help of the determinant matrix. And results and discussions. In this results and discussions section, photonic crystal structures classifications are made on the basis of part lengths of the photonic crystals, tripartite photonic crystals that you can remember. And therefore, with the light of the in the light of these classifications, 4 different structures, electromagnetic wave propagation frequencies will be examined. Here you can see. Yes, here you can see the structure classifications according to the part lengths. We can classify them in 4 different groups. Here, in the S1 structure, here there are 3 parts. This S1 structure is tripartite, S2 structure is tripartite, but part lengths changes that here. Be careful. And in the structure 3, also there are 3 parts, but in the structure 4, there are only 2 parts. There are only 2 parts, and the positions x1 and x2 changes. Yes, we can be careful because according to the part lengths, the electromagnetic wave propagation frequencies can be adjusted. So we should be careful about the part lengths. Yes, you can see the structure classifications, and we calculated propagation frequencies, electromagnetic wave propagation frequencies for all 4 different structure, photonic crystal structures. And in these structures, this table shows 6 different groups. You can see with different material properties for each part. Part 1's material properties here you can see, and in the middle of the chart you can see the part 2's material properties, and part 3's in the right side. You can see the part 3's material properties of the photonic crystal. And I should also say that here the highest material property parameters are in group 6, whereas the lowest material property parameters are in group 1. You can here see. You can see here. And there are the results that from the analysis I obtained for the tripartite and bipartite photonic crystals, and I can say in the summary that the highest electromagnetic wave propagation frequencies are obtained for the bipartite photonic crystal structures, as I called it S4 photonic crystal. This photonic crystal is called as S4. I showed its figure before in the previous slides, and why we obtained the highest electromagnetic wave propagation frequencies for S4 photonic crystal structures. This is because of the part lengths. Because of the part lengths, low material parameters predominate in the structure, so you can obtain the highest electromagnetic wave propagation frequencies. On the other hand, the lowest electromagnetic wave propagation frequencies are obtained in the tripartite S1 photonic crystal structures. Why? This is because of the part lengths. This is also because of the part lengths. Why? Because high material property parameters predominate because of the part lengths in this S1 structure. And in this study, it should be noted that electromagnetic wave propagation frequencies can be adjusted according to the part lengths of the three-party photonic crystal structures. And here you can see the S1. Here you can see the electromagnetic wave propagation frequencies of the S1 photonic crystal structures. In the left side and right side, the frequencies of S2 photonic crystal structures, and in the left side you can see the electromagnetic wave propagation structures.
Before breaking, could you please complete time?
Yes, 3. Okay, okay.
10 minutes ago.
Okay, and yeah. I can finally, in the summary, says in the future studies, same analysis can be implemented to 2D and 3D photonic crystal structures. I can also say it. Yes, thank you.
Is there any question, comments, or remark? No question. Thank you very much for your presentation. The name of the next speaker is Görkem Serbest. The title of his talk is Enhance Sparse Representation of Spike Waveforms Obtained by Using the Basis Pursuit Approach. Okay.
Thank you very much for giving this opportunity to talk to me. Can you hear me?
Yes, and I can see your screen. You can start.
Thank you very much. And I would like to thank for all the contributors for their attention. Today, my talking topic will be enhanced sparse representation of spike waveforms obtained by the wavelet transforms. My name is Görkem. I am an assistant professor in the Biomedical Engineering Department of Yıldız Technical University. This is my outline actually, but we have some time limitations. That's why I directly go into the concepts. So when we try to describe the problem, actually our methods can be applied to any type of signals, but especially biomedical signals, which comes from the living organisms. When we look at their nature, they are in non-stationary character, which means the signal of interest can be show itself in any time. So that's why the normal Fourier transform, which assumes that the analyzed signal is stationary, has some limited contribution because it doesn't give some time information to us. For example, in here, we have a speech signal and we get the Fourier transform of it. As you see, we can get the power, the magnitudes of the contribution of the signal for a specific frequency, but we don't have any time information. In literature, the window Fourier transform or the short time Fourier transform, which uses some small windows to divide signal into some smaller parts and get the Fourier transform, the frequency information under the part of this window, actually has an enhancement because it gives us some time information due to having a window which can be shifted in time. But when we look at the characteristic of it, we cannot change the length or the width of this window during the analysis. That's why it gives us a fixed time or frequency resolution. But when we look at the nature of biomedical signals, we can see some different morphological properties like oscillative signals, which needs high frequency resolution to be analyzed, and also some transient waveforms, which occurs in a very small time interval and needs a good time resolution during the analysis. And to be able to get that, mostly in literature, we use the wavelet transforms. The left side formula is the continuous wavelet transforms formula. It's actually a time scale representation, and the scale is the inverse of frequency, so it's related with frequency. But most of the times we use a fast algorithm that is called as discrete wavelet transform, DWT, which gives us the right side upper part time scale tiling. And as you see in this one, the x-axis is time and the y-axis is the frequency. As you see, for the high frequency components, we get a better time resolution. On the other hand, we get a good frequency resolution for the low frequencies. So the type of signal that we are aiming to use in the analysis by using the wavelet transform is the extracellular neuronal activity of our brain. So when we look at the general problem, to design brain-machine interfaces like this, there are some invasive and non-invasive methods to get information from the brain. And in the extracellular recordings, some very tiny multi-electrodes are embedded into brain and get the individual activity of neurons. But when we just think the size of the tip of an electrode, mostly they record multiple neural activities. And to be able to understand the information content of these recordings, we should assign the individual activity of a neuron to its action potential, which we call as spike in the study. So this is called as the spike sorting problem. So when we can get the sorted versions of these individual activities, then we can decode the information and use it, for example, to control a prosthetic arm. When we look at the spike sorting problem a little bit in more detail, as you see in here, we have an electrode, and in the tip of the electrode, 3, 4, or 5 neurons activity can be recorded as a raw data. But in this raw data, we have also some noise components. For example, the local field potentials, which is the superimposed activity of nearby neurons, which is shown as blue area in here. And also, of course, we have some the acquisition system based noise. So to be able to get relevant information from the raw data, first we use linear filtering and get rid of the noise components and also the power line noise component, 50 Hertz in Turkey. And after that, from the filtered data, we use some thresholding methods in practice to get the locations of these spikes, and the spikes detection problem is the name of this. And after that, from each detected spike, we use some feature extraction methods to get some discriminative information that can be used in spike sorting, which means assigning an individual activity to the relevant neuron. And actually in nature, it's a clustering problem. And when we apply this, at the end, we get the red and blue is shown like this, the neuronal activity of individual neurons. So in the spike sorting problem, in the right side, we have the neuronal morphological or time domain behavior of the action potentials that are used in the study. Actually, they're obtained from a raw data, filtered raw data actually, which is shown in the upper part. And today, we will use an enhanced wavelet transform to extract features from these spike waveforms, which has an enhanced ability of differentiate these activities, these time domain behavior activities. In literature, practically, there are two main approaches for this. One of them is the PCA, principal component analysis, and the other one is the discrete wavelet transform, but lately discrete wavelet transform is used more because of the time information catching ability of it. But mostly in literature, the used discrete wavelet transform has constant Q factor filters, and an enhanced sparsity representation cannot be obtained by them. In this study, instead of using classical dyadic wavelet transforms, we use a tunable Q factor wavelet transform, which is a fully discrete application. The Q factor is the actually ratio of the center frequency of the wavelet filters to its bandwidth. Okay, so when you have high Q factor filters, it means your filter response have some narrow interval, which means they mimic more oscillative behaviors. But vice versa, if you have a low Q factor, they have more wideband response, which actually mimics the behavior of transient signals like action potentials in here, spikes. We will try to use a low Q factor approach with an enhanced sparsity property in our proposed application. So there are three parameters of this tunable Q factor wavelet transform. The Q, obviously, which actually lets us to set or tune the time domain behavior of our filters. Redundancy, R, this is an oversampled transform, overcomplete transform, which means you can get a numerous of set of coefficients which actually represent the same signal. Okay, so you can arrange by changing the Q factor, you can get different representations with different number of coefficients, and this results in redundancy. And obviously, J is the number of states. So it is the number of used filters which divides your frequency axis into subbands. One novelty that we use the basis pursuit approach to obtain the enhanced sparsity. In this formula, actually this W is the wavelet coefficients, and during the analysis, these wavelet coefficients are the output of the transform, while the filter part, the left part, is fixed. So by using Q factor and redundancy factors, you can get different wavelet coefficient sets, which actually represents the same signal. But if you use the basis pursuit approach in L1 norm minimization, we can get the enhanced sparsity behavior. And sparsity means you get some coefficient set actually in a reduced number with high amplitudes. So to understand it in a better way, so let's show the applied versions of this tunable Q factor wavelet transform. These are three different types of signals. Their morphological characteristic is very same. The only difference is their width. So when we apply the normal tunable Q factor with a low Q value, as you see, a homogeneous, these are the coefficients in different subbands, in different levels. And in the right side, we have the energy distribution of each level. There's some will be of these 100s. As you see, a more homogeneous distribution can be obtained. But when we use the enhanced sparsity basis pursuit approach, as you may see in the left side, when a low Q factor is used, even we have very similar behaviors, their coefficients can be localized in three different regions with a very localized, very concentrated energy. So that's actually our aim. We will try to get the sparse representation of the spikes, the action potentials, and if we can do it properly, we hopefully intend to get more discriminating behavior. So the data set that we are using is recorded from the neocortex and basal ganglia from a previous study, which is given in this bottom line. They have a very well-designed background noise because they use actual real-world spikes, which represents the local field potential actually. In each recording, 3 different spike waveforms are represented. So our aim is to classify them. And actually, these 3 different spike waveforms has a normalized amplitude to 1 and 8 different noise levels starting from 0.05 to 0.4 is superimposed onto this activity. The sampling rate was 24 kilohertz, and the localization is parallel with the Poisson distribution, which has an interspike interval of 2 milliseconds, which we can call this as the refractory period, is the interval between the activity of same spike. In our proposed approach, we used only non-overlapped spikes because overlap means if we have 2 different neurons which fire in the same time, their activity will be superimposed. We call this as an overlapping activity, but our aim is just to measure the discrimination ability of our approach. So to get more objective results, we just ignore this overlapping cases and concentrate on non-overlapping parts. And each sample in our study has 64 time points. The distribution of the set, firstly, each 3 classes, each 3 waveforms has a very similar distribution. Their numbers are almost equal. And we divide our data set into 2 parts, and 8% of the samples are used for training and validation, and the remaining 20 samples is just used for testing. And in the training and validation set, we use a k-fold with a k value of 5 is used. This is our general approach. We get the spikes from the long recordings and create our data sets. Each consists of 64 samples of 3 different classes. We used for the feature extraction the TQVT, tunable Q-Wavelet transform with an enhanced sparsity by using the basis Persis methods. And as the feature, we use the energy of each subband. So we have some 6 levels of, for example, decomposition. We will get 7 features, the 6 detailed energy and 1 approximation energy. Then we divide into 2. We use as the learning models KNN and decision trees. Actually, by its nature, this is a clustering problem, but our aim is just showing the capability of tunable Q-Wavelet transform to discriminate the waveforms. That's why we assume this problem as a classification problem. But in real case, in real-time working studies, this should be interpreted as a clustering problem. We choose the best model and get the accuracy values. We use 2 approaches to validate our study methods. One of them is the qualitative results. In the qualitative results, for a spike that is taken from our database, is decomposed by using the TQVT when Q is equal to 1. When the sparsity is used on the right side and not used. And as you see, when the enhanced sparsity is applied, more sparse and more concentrated energy. So these energy values actually used as our features. As you see, more localized energy distribution can be obtained. And in the second case, we present our quantitative results for the validation set and also for the test set. In the validation set, we have the average and standard deviation values because we have 5 folds for both KNN and decision trees. And on the right side, for without sparsity on the upper and with sparsity, enhanced sparsity on the lower case, we have the test set results. And when you look at these results for both of the classifiers, when the sparsity, enhanced sparsity is used, like 15 or 20% increases in the accuracies are obtained. And this is obviously show us that if we use the enhanced sparsity, we can get more discriminative features. And when we look at the standard deviations of them, the enhanced sparsity cases has lower standard deviations, which shows actually the features obtained by enhanced sparsity are more robust. In real cases, in real applications, if your data acquisition system is not well designed, you will get a high level of noise, like 0.25 to 0.40. And this 0.40 means the power of your noise is the 40% when you compare with the power of spike. It's a very high level of noise. Even in that noise, our approach has like 98% 5 accuracy. And when we conclude our study and give some future remarks, instead of the classical dyadic wavelet transforms, the tunable Q-wavelet transform used as a feature extractor with an enhanced sparsity obtained by basis process approach. And in our scenario, we prove that by using 2 classifiers, we use KNN and decision trees because they do not need hyperparameter tuning that much, and we assume that they will give some objective results. For both of them, we have 15 to 20% accuracy increases, which shows that our approach can be very useful in these kind of studies. And as a feature remark for here, we just used non-overlapping spikes as our input database. And in future, we are planning to add the overlapping spike cases and measure the success of our approach. So thank you. That's the end of my presentation. If you have questions, I would be happy to answer.
Is there any question, comments, or remark? No question? Thank you very much for your presentation.
Okay, thanks.
The name of the next speaker is Ufuk Korkmaz. The title of the talk is Mimicking an Information Reservoir by Superconducting Quantum Circuits. Okay. We can see your screen. You can start.
Hello everyone, my name is Ufuk Korkmaz. I am postdoc researcher in the field of quantum information theory at Istanbul Technical University. On behalf of other authors, I present Mimicking an Information Reservoir by Superconducting Quantum Circuits. The objective of the paper first is to report the analytical result of the operating principle of the proposed open quantum classifier. We exploit the additivity of quantum dynamics map for the distributive process in the weak coupling regime, where optimized time-dependent control is not required to achieve the classification result. Second, we demonstrate the quantum equilibration process by mimicking a quantum information reservoir based on a superconducting quantum circuit architecture. Superconducting quantum circuits are currently the driving force for the implementation of the quantum information processing. An important feature of superconducting qubits are that many control parameters, such as interqubit coupling rates, are tunable and well characterized. By using the heuristic parameter in our numerical calculation, we also demonstrate the physical implementation of collisional models, and the equilibration process in the presence of an information reservoir is feasible. We first describe quantum information reservoir composed of identical and non-correlated qubits in accordance with the collisional model. The quantum state of each reservoir qubit is parameterized by polar and azimuthal angles, as in the well-known block-square representation. Throughout of our study, we take phi equal to 0 fixed and donate the amplitude parameters by theta. We employ density matrix formalism in our study to represent the quantum state of the system in question. Here is the cat state density matrix representation for the probe qubit, and here is the block share representation density matrix representation for the reservoir qubit. The unitary propagators define each collisions between the probe qubit and each reservoir in this formula. The Hamiltonian described the entire system during the interaction between the probe qubit and the free term of the Hamiltonian. We write in this form, h bar here is the Planck constant divided by 2 pi, omega 0 and omega I are the frequencies of the probe and the reservoir qubits, sigma 0z and sigma iz are the Pauli Z operator for the probe qubits. We consider the resonant case omega 0 equal to omega I, hence the interaction Hamiltonian we can write in this form. Gi is the coupling coefficient between probe qubit and inter-reservoir. Sigma 0 plus sigma I minus are the Pauli rising and traveling operator for the qubits. For the Markovian reservoir case, the information reservoir have no interaction each other. After each interaction, the system of interest obtained by tracing out the environmental degrees of freedom, as in this formula, by using the realistic dynamic, where n2 is the time elapsed for n collision. In this section, we implement the proposed method of the paper with realistic parameters by using an architecture composite of true transmit qubits coupled to a coplanar waveguide resonator. The coplanar waveguide serves for coupling of the qubits as well as qubit readout. We use an effective Hamiltonian to describe the proposed system. In this equation, first two terms to describe of the transmit qubits. Third terms is the described between transmit qubit and the coplanar waveguide, and the last term is the interaction term of the transmit qubits. Omega 1 and omega 2 are the respective frequency of qubits. Omega R stands for the resonator frequency of the coupling medium. A and A dagger are the bosonic annihilation and creation operator. G is the flip-flop type effective coupling between transmit qubits. And here in this formula, G1 and G2 are coupling strengths between the qubits. The frequency shift of the respective qubits we can find in this formula. Initially, we prepare the system in a product state as the tensor product scheme. Rho-S is the thermal harmonic oscillator density matrix of the coplanar waveguide with a thermal excitation number. Rho Q1 is the probe qubit density matrix. Rho Q2 is the reservoir qubit density matrix. We write again unitary propagator in this form. After each interaction process, the probe qubit should be distinguished from the other density matrices. Moreover, the reservoir qubit should be reset to its initial state before its next interaction. It means that Markovian regime. Current state of the art allows for an energy dissipation time in the T1 between 50 to 100 microsecond time scale, while TR between 1 to 10 nanoseconds is a single qubit reset time. Here is the realistic parameter for the numerical calculation. We obtain the dimensionless parameters by scaling the realistic parameter by divided WR. We can clearly see that G2 is satisfying the weak coupling condition. Equilibration dynamics of the probe qubit magnetization against the collisional number depending on the reservoir qubit amplitude parameter theta. Theta we take in this plot three different values. A smooth variation of the equilibration curve exhibits the verification of our Markov evaluation. It's observed that as a result of oscillation, the curves broaden for smaller values of the theta implying a quantum reservoir with large non-equilibrium intensity. It's obvious that the probe qubit reaches the steady state after 2000 collisions. The equilibration takes place before the qubit dissipation time, which makes the proposed setup experimentally feasible. Trajectory of the work vector during the collision
Sorry for breaking. Sorry for breaking. We can see only introduction slides.
Can you see?
Now, yes. Now, yes.
Sorry, I
Ninth.
don't understand.
Okay.
What.
Okay.
The amplitude parameter of the reservoir is theta equal to P. The shrink of the work sphere is a Waveguides directed to standard amplitude damping channel with a smooth trajectory of the work vector. We can conclude that the collision equilibration of a probe qubit is experimentally feasible in the presence of an information reservoir with the given superconducting circuit parameters. We examined the idea that quantum reservoirs could be harnessed as information sources. By driving a master equation, we propose a classifier model that returns a binary decision in steady state depending on the parameters of multiple distinct quantum information bearing reservoirs and the coupling rates. We analytically verify that a single probe qubit in which it serves for readout can classify the quantum information encoder and the reservoir qubits. As the proposed model was established upon the equilibration dynamics, we also examined the experimental feasibility of the model based on the realistic parameters of a superconducting architecture in the transmon region. In our numerical calculation, we showed that the collision equilibration dynamics on which the main assumption of the proposal is based can be successfully implemented in a real quantum information processing system. We note that the additivity of quantum dynamical maps allows for any number of input information units without the need for the time-dependent control. Our result may contribute to the dissipation-based quantum information task. Thank you for the attention.
Is there any question, comments, or remark? What kind of numerical method have you used?
I use Python qubit library.
Let's see. So that study has been supported by the Scientific and Technological Research Council of Turkey, right? Under a national project?
Yes, yes, TÜBİTAK, yes.
So you're a researcher?
Yes, I am a researcher.
Okay. Thank you very much for your presentation.
You are welcome. Thank you too.
The name of the next speaker is Ecem İren. The title of the talk is Data-Driven Software Testing with Selenium Approach, POI tool.
Okay, hi everyone. Can you hear me and see my
Yes.
representation?
Yes, we can hear you and we can see your screen. Okay. You can start your talk.
Thank you very much. Today I will talk about data-driven software testing with Selenium Apache POI tool. My name is Ecem İren. I am working in İzmir Kavram Vocational School as an instructor. If I talk about aim of the study, the aim of study is investigating and giving a brief information about both Apache POI library of Selenium test tool and data-driven testing of software systems. Therefore, in the context of study, a data-driven test application is implemented with Apache POI library of Selenium in order to perform our test scenario. Then test methods are executed and test results are examined. Finally, it is understood that data-driven testing can be carried out easily with built-in methods of Apache POI library and can be installed for free by the users for testing purposes. And building methods can be used to access and get data for testing process. Firstly, what is software quality? The concept of quality in software means that the software meets needs and expectations of the customers and also free from defects and errors. Quality software saves time and money since it is unlikely to occur errors in testing and maintenance states. Assuring the quality of the software is related with software testing process also. Testing is the process of controlling the system carefully from different aspects, either manually or automatically, to see if it concords with customer requirements. There are furthermore many reasons to test the software, such as making sure the product quality before it is present to the customer, reducing rework and development cost, and detecting errors in the early stages of the development process, and finally preventing them from spreading further stages. I want to talk about types of software testing also. For example, functional testing is a kind of test level where software is controlled based on its requirements. It checks the results of a given set of data by comparing them with the expected result set. Therefore, it is operated as result-oriented. Regression tests are performed after the necessary corrections are made in the application. The problems identified in the previous tests are resolved and that new errors won't occur. On the other hand, performance tests is often used synonymously with load test. It can also be defined as the workability test of a system under heavy conditions like unexpectedly loads, a huge increase in requests to the web page, very intensive numerical operations, or complex queries made to the database systems. User acceptance tests are done by the users to determine to what extent the application meets the requirements before accepting the application. White box testing technique is called as code testing. In fact, source code of the project is test in this stage. For example, flow controls, if-else conditions in software code. Elements are analyzed in stage variables also. Hence, such tests depend on knowledge of the internal logic of the application code. Black box testing is a process of checking the application through interface, web page interface. In this test technique, knowledge of coding is not required. Automatization of test process. Automatization is preferred to increase effectiveness and execution speed in software testing. Manual testing can be time-consuming and it can cause some defects if tester doesn't analyze carefully the test scenario. In addition, manual testing can become boring and hence error-prone. Test automation in software testing doesn't require any human intervention. Test cases can be run in any time automatically. Since also we can operate several test cases in parallel, test automation increases the speed of test execution. One of the most important features of automation testing is the prevent errors that may occur due to human interaction during the testing process. Which test cases to automate? Test cases can be automated in the applications which has the following criteria. Critical functions for business in application, test cases that are repeatedly executed, test cases that are complex to perform manually, test cases which are time-consuming. It means executing in long time. Data-driven testing approach is a software testing method in which test data is stored in table or spreadsheet format. Data-driven testing allows testers to input a single test script that checks all test data from a table. It is also called, therefore, table-driven testing. In this technique, input data are read from data files and stored into variables in test scripts. You can see from the figure also. Data sets can be stored in Excel file, XML file, CSV, or in databases. Selenium test tool is an automation tool. It is useful for write our test cases and operate them in a short time. It is an open source and web-based testing tool used to automate test cases and improve performance. It has become an important tool in addition due to the complexity of testing process with the expansion of web applications. It includes various testing functions for the testing of web applications on different browser platforms. For example, Google Chrome, Internet Explorer, Firefox, and like that. It also can be run on different operating systems and can be controlled by different programming languages. We can write test scripts, for example, in Python or in Java, in Selenium test tool. How does it work? Firstly, the automation script is run. For each Selenium command, an HTTP request is created and sent to the browser driver. The browser driver uses an HTTP server to receive HTTP requests, and then the HTTP server determines the necessary steps to implement the Selenium command. Web server helps with the backend, and the browser acts accordingly. Steps are executed on the browser. Moreover, Selenium has a WebDriver API is used to interact with web page elements and to generate test scripts. And you can see also the working principle of Selenium test script, browser and server relationships can be seen like that. Apache PUI library of Selenium is a popular API that allows programmers to create, modify, and view Microsoft Office files using Java programs. It's an open source library developed and distributed by the Apache Software Corporation and contains different classes, methods to work with Microsoft Office documents. Moreover, the service is divided into different components, such as horrible spreadsheet format. It is used to read and write XLS format of Microsoft Excel files. XML spreadsheet format, it is used to read and write XLSX formats of Microsoft Excel files. XML word processor format is useful for Word file. Horrible slide layout format can be preferred in PowerPoint representations, and horrible diagram format is required for MS Visio files. In our application, we implemented in NetBeans editor and with Java programming language. A new project has been created in the NetBeans tool to perform database Excel tests. Relevant jar files should be added to the build directory of the project as seen in figure 3. In addition, the test-ng tool is used for performing tests and reporting of test results. This is, you can see Apache PUI libraries of Selenium tool. We should integrate with our NetBeans editor to use it. I try to explain this in this page. An Excel list is created for testing. In this list, information such as user email address and password are stored. In this project, email addresses and passwords of the users are read respectively from the Excel file and direct to the Gmail login page. In order to extract the relevant data from the Excel file, a separate Excel operation class you can see from the figure sorry, 4, it should be, has been created as follows. We use some variables, workbook, sheet. This is Excel workbook, this is Excel sheet they represent. And these classes come from the Apache PUI library. We did some adjustments in the constructor, you can see in this part. In this class, some variables are created from the classes defined in the Apache PUI library to access the target Excel file and worksheet, including test data. The directory of the Excel file and the name of Excel worksheet are given as parameters to the constructor method of the class. Therefore, user should specify appropriate parameter values while creating an object of this class. In this method, the file input stream object is defined with the directory name of Excel file parameter, and then Excel workbook is accessed with this object. Then, with the help of the Excel workbook object, the worksheet is accessed. Here, a separate test class has been created for database testing. You can see it can be seen in figure 4. Here, the Chrome driver is defined and the web page to which the application will be automatically redirected is specified. In this test, we test the Gmail web page. In fact, in Excel file, the user email and passwords are stored, and we test those data for login Gmail. This is data-driven test. You can see we use before method tag here, before the method. If there is a method to be run before test automation in test-ng, this is done by adding the at before test notation to the relevant method. This notation has been added to the beginning of the init method, where necessary adjustments are made before the test will be run before the test. In this stage, we should create a data provider. For creating data provider, we use
Sorry for breaking. Could you please complete? 15 minutes have been passed. Time's up.
Okay. A data provider is needed for database testing, and this data set is created with the array filled with Excel data illustrated in figure 5 by giving a special name in the parameters. This is Excel sheet, Excel file name. This is Excel sheet name. Volume testing name of the data set described with data provider before the test method shown in figure 6. Then it is necessary to determine the appropriate fields on the web page with Selenium built-in method. Username and password fields are accessed with XPath method. After the fields are decided, the data values in dataset are sent to those fields, and the login process of the web page is done automatically. The success of the test is determined by the URL information of the web page. The current URL is compared with the expected URL, and the test result is considered as successful if both are equal. Otherwise, the test will fail. Our test is successful. You can see it passed. In the scope of study, a data-driven test application is written with Apache PUI library of Selenium test tool in order to perform our test scenario. Then the test methods are executed and the results are examined. Selenium is free of charge and can be easily installed installed by the users for testing purposes. Our aim is to give information about both Selenium tool and data-driven testing for the people who are interested in testing operations. Thank you very much for your listening. That's all for me.
Is there any question, comment, or remark? Thank you very much for your presentation.
You are welcome. Thank you.
The name of the next speaker is Svetlana Stoyanov. The title of the talk is System Analysis and Design Algorithm Drives Through Innovative Software Approach.
Hi, can you hear me?
Yes.
I will share my screen. This is my presentation. I will present a study, system analysis and design of gear drives through innovative software approach. In this study, this study has been performed from Professor Antoaneta Dobreva, and I have been assisted to her. The in contemporary world, the energy efficiency is major question, and this is the reason because we perform this study to increase the efficiency of worm gears. So we have been perform an analysis of some literature source to find the possibilities for do these improvements, and this work in this study have been this is some other research for this and this research is listed here. So we we in the field of worm gear systems know significant theoretical models that have been found having the purpose to improve their functional capability. And this is on this screen the mathematical of research. And this is the results on these pictures. For efficiency matching coefficient of the worm gear drive, depending of the change of the module and the gear ratio at the center distance. This is the picture for other center distance, and some center distances have been studied. On these screens, and in conclusions, we can say that we have improved methodology for calculation of gear efficiency for worm gears. And thank you for your attention. This is my presentation. This is all that I will comment. So, can you hear me?
Yes, I hear you.
Okay.
I think start another presentation, maybe.
Yes, you can start another.
Okay.
I think we go on another presentation.
Right. The next speaker of this session is Lama Sublaban. The title of the talk is Exploring Exception Handling Mechanism in Android Application Development.
Can you hear me?
Yes.
Okay. Can you see my screen?
You can share your screen and start.
I shared my screen. Can you see it?
Right. Okay. Yes.
Okay.
Yes.
Amazing. I'll start now. Thank you for having me. My name is Lama Sublaban. I did the research of classifying code comments usage in Android application development, alongside with my colleague and supervisor, Dr. Samer Zain, for Birzeit University. We're gonna discuss introduction and related work. Then we're gonna talk about the methodology, then the results and conclusion. You can see my screen moving, right? I think yes. So
yes.
Okay, for introduction, new records show that 50% of the population at the moment owns mobile devices. Also, we have more than 3 million Android applications that have been developed and published on Google Play Store. We all know that Android applications are actually written in Java. This is just for everybody to remember the comments that can be divided into two basic types. The first type is called actually the single line, as you can see, for example, in the code snippet at line 4, I mean. There's also a second type called multi-line comment that can be seen, for example, from line 5 until line 7. This is just a simple reminder, of course. Our research objectives were as the following. We wanted to classify and study the categorization of in-code comments usage inside Android application development. We also wanted to study the source code of some chosen representative sample of Android application that we chose on a criteria that I'm going to speak about, in order to study the comment types and usage in a quantitative manner that evaluates to the comment quality in Android application development. We also wanted to build a preliminary vision of how the usage of comments should be made and used in terms of its types in the Android applications that are now, of course, playing vital roles in our day-to-day operations. The literature review, in a nutshell, as everybody, we use the databases like Google Scholar, Springer, and IEEE databases with the main keyword of search, which was code comment classifications and usage. In the past 15 years, the surface of literature, specifically in this main topic, actually have emerged to the surface of the literature. Our categorization of literature review was divided to 3 main categories. First one was studies on documentation quality. The second was the Android application code studies, and the third literature review coverage was studies on classifications of code comments, actually. Our methodology was as the following. For the workbench, we had some rules to choose a representative application sample based on. The first was that the target platforms of this study were actually real-world Android applications, and they needed to be open source, of course, and exist on both Google Play Store and F-Droid open source library. The source code had also to be on GitHub, so that will be fully open source and we can play with it as much as we want. Also, The chosen apps belong to the most popular applications section in the Asteroid library, which is an open source library. We chose 24 applications from 6 main categories in Asteroid library, 4 for each category. The categories were as the following: health, internet, money, multimedia, navigation, and system applications. The targeted applications were analyzed at the source code level using a tool that was developed specifically for this research. Normally, as per our literature review that we just spoke how we divided it, the researchers in all nearly of the researches that we went along used actually a parser to parse the source code of an application so that they can extract the code and that they are targeting to a text file, then they will analyze it. In our case, we developed our own parser and automated the tool to parse all the code comments in the 24 applications. Then also, not just automation, we also did manual work of classifying 50 files to set our classification taxonomy. We're going to all speak about it in a moment. The tool analyzes actually the extract comment blocks to understand and classify the types of comments that are used in the target applications and how many times they have occurred in statistical classification way. This is a simple activity diagram, an explanation of how our parser works. In a nutshell, it goes inside the application in all the files, it reads them all, it gets specifically the code blocks 10 lines before, 10 lines after, and it extracts the code block of comments. Then we analyze them automatically based on the type of them. I'll be happily answering any questions you have about this after the presentation. The results and discussions were as the following. The code comments in the applications. I cannot see some of the screen, 1 second. Seems that, okay, here we go. The code comment application is the application lines, basically the percentage of the results of the total single line source code comments with 4% of the total lines of code of all the 24 applications that we studied. The percentage for the total multi-line source code comments were 8% of the total line of code. As you can see, this metric actually allows us to understand the overall mentality of how the code comments are used by the programmers in the Android applications. You can see in this table and graph in front of you all the 6 categories that we studied and the application lock, which is line of code, towards the single line and the multi-line in each category. Another section is code comments classification taxonomy. This metric actually allows us to understand the overall mentality of how the comments were actually classified and how were they used by the programmers in the Android application development. Basically, the tool came in, it counted all the comment blocks based on some grid methods that we used to their types, then it calculated the redundant value of them. Then we manually inspected the comment blocks of the 50 files, as I mentioned, so that we can get all the classification from them correctly according to the redundant value, just to double check if our values were right or wrong. The results are in the next slides. These are all the classification taxonomy that we came up with. As you can see, there are 10. Usage, link, exception, summary, metadata, deprecated, like all of these are the classification taxonomy in front of you. The dominant classification in our result was actually the developer node comments. They came back with percentage of 33% of all the applications. The second was the summary with the score of 28%. These results actually indicate that comments here are made toward end users rather than the developers themselves. For example, the under development comments came back with a percentage of less than 1% from total comment of all the applications. This actually directly indicates that the developers are using different ways to communicate with each other. The code comment user in applications, this metric reflects the previous metric results as what? As the classified code comments in all the applications categories as an overall results for all the applications and specific results of each main category. How? Basically, we just saw 10 classification taxonomy that are dominating, but actually we have 4 that are dominating in the code comment blocks terms of usage of the commenting practice in every application category. They are developer notes, summary and usage, and metadata. The conclusion, in a nutshell, basically, as per our knowledge from researching the literature, this is the first study that aims actually to study how the programmers are using the code comments inside the Android applications development and provide a valid classification specifically for them. Our study contributes directly in creating a tool to parse the total source code of the application and extract the code comment blocks from it, then to automate its static analysis in order to indicate the classification in percentages and occurrence or usage of code commenting practices used in targeted applications. The total comment blocks found are 11% of total application block, yani about 30,000 out of the 300,000. Out of them, the multi-line comments were about 8% and single-line comments were about 4%. The 24% of total comments were dedicated for the metadata, version, and auto-generated comments. So if we remove them, as some researchers suggested, we will have a total of 7% comments out of the code of all the applications rather than 11%. 7% for important comments classification is relatively low, lower than expected, since the usage of comments as a documentation practice is very important and mandatory. Our results show that the usage of comments on declaration of the application level is presented in 6 application categories in high numbers, which has actually a good and bad side. First, the auto-generated comments mark an extremely low occurrence in the comment classification of all programs under study, with an extremely low percentage of less than 1%, which indicates that the developers cared about their Android application code so that they wrote over the auto-generated comments that the IDE makes automatically in Java as an object-oriented programming language. Another significant result that our results reflect is that the developer notes and usage comments dominate the classification results in nearly all the apps under test. This actually imposes the most of the application. Comments were carefully written across the source code inside the function and the method in most of the single comment lines to explain what the code does. As for the future work, in a nutshell, we aim to do the future work by developing more in the tool, of course, to build that we built for this research, by making it more as a compiler, not just a static analysis, so that it will both do a static analysis to understand the code without running it fully to continue on classifying the comments in each life cycle of the application. These are the references, and if you have any questions, please let me know about them. Thank you for having me, and thank you for listening.
Thank you very much for your presentation. Is there any question, comments, or remark?
Thank you.
No question. Thank you very much for your presentation.
Thank you for having me. Thank you so much.
Okay. The last speaker of this session is Todor Todorov, but I think he's probably absent, right? Yes. Thank you very much for your participation to this international symposium.
Thank you.
I wish you have a great success in your academic life and wishing to meet in other international symposium and conferences.
Thank you very much for the organization.
Thank you very much.
Thanks.